Hey there, algebra. Lesson 25. We only have lesson 25 and 26 left for unit 2, which is pretty cool. We're getting close to the end. To start here, we can look at which one doesn't belong. Graphs of solutions. So I have 4 graphs, and we can discuss which one doesn't belong. And this is great because there's always a right answer no matter what you think and no matter what your mind goes to. If I look at A, just sneeze, excuse me. A, they're 2 linear equations. These are not inequalities, these are equalities. So the equations have equal signs in them. And where the 2 lines cross, there is only one solution. All right? So we could say that one doesn't belong because there's only one solution. Or if I look at B, I have one equation that is greater than with the same slope as the other equation, which is less than. Okay, so if I have 2 lines, if I have 2 equalities with the same slope, then there's no solution because those equations never intersect. Well, if I have 2 inequalities with the same slope, and one is greater than and one is less than, then I have no solution also. So here I have no solution because those shaded areas do not overlap. If I look at C, I have a linear inequality, which is just, this looks like y is greater than or equal to 5.5, and this is x is greater than or equal to 5.5, which is fine. Where they overlap is right here, and this is considered the solution. Then here I only have one inequality. Okay, those are all the sort of differences between all the graphs. All right, let's jump on in, focusing on the details. Here are the graphs of any of the inequalities in this system. So I've got this system over here and it's graphed right there. All right. Decide whether each point is a solution to the system. Be prepared to explain how you know. Well, I can graph them. So if I go over 3, down -5, 2, 4, 5, this would be no, because it's not in both shaded areas. If I look at 0, 5, 0, 2, 4, 5, yes. It's in the doubly shaded area. -6, +6, so -6, 2, 4, 6. It's right on that line, but it's a line, not a dashed line. So yes. But for this one, sometimes they're a little bit, the graphs aren't drawn very well, especially when I draw them myself. So I'm going to check really quick in this system by plugging them in. And that one's written backwards, just saying. So I'm going to flip it around. So for this first system, I know that x is -6. So I have 6 greater than -6. That is true. And over here we have 6 greater than or equal to -2 times 6 minus 6. So -12 minus 6 is -18. Hold on. X is negative. There we go. +12. So 6. Is 6 greater than or equal to 6? Yes. So that number 3 does work. Okay, it's right on that line, but it's an equality line, so it can be on the line. Now 3, 3, 2, 3, 2, 3. It's right here, but that line is dashed. So ordered pairs that are on that dashed line are not included. It's on the dashed line. And I can show you that's this line. Y is greater than x. Is 3 greater than 3? No. 3 is equal to 3. It's not greater than. And then -2, -2. So -2, -2 is right here. Unfortunately, it's on a solid line and a dashed line, so that doesn't work. And let's double check to make sure. If I put it in the first equation, I have -2 greater than -2. That's a no. If I put it in the second equation, not that it matters, I have -2 is greater than or equal to -2 times -2, -6. So +4 minus 6 is -2. So that second equation is true, but the first equation is not, so it's a definite no, okay? Okay, this is a great, are you ready for more? Coming up with equations for all three of these lines. It would be that line shaded less than or equal to. You have to come up with equations. This line shaded less than or equal to, and then this last line shaded greater than or equal to. So that's a system of 3 inequalities. You'd have 3 equations all in sync. And your solution to the 3 systems is where things are triply shaded, right in that area. All right, so info gap we're going to do in class. Okay. Hopefully if I can figure it out as a full class exercise. Okay, so I'm going to stop the video here. Good job.